for this video, I'm going to be going over Sig Fig rules with you guys. I am going to tell you I'm not going to work every single problem with you, but I will work a few that way, but I will have them worked out on the key so that you can go check your answers if you work them out yourself. So let's start with Sig Fig rules. So how do we determine Sig Figs? So first thing it says is that all non-zero numbers are significant. So if a number is not zero, it's automatically significant. So like right here, we have 3.98. How many significant figures would it have? Ooh, my bad. It would have 3 because 3, 8, and 9 are all not significant. 938.3 would have 4 because it has 4 numbers that don't have significant figures. So if it's not zero, it's significant. Now, zeros, there's 3 cases. Number 1, zero, leading zeros. These are zeros that precede non-zero digits. Leading zeros, so zeros that become before a significant digit, are never significant. So in this case, like these first 3 numbers are not significant, so that only has 2 significant figures. Same thing here, leadings aren't significant, so again, that one would have 2 significant figures. All right, next our sandwich rule. All zeros between non-zero digits are always significant. So like 2013, that 0 is significant because it's sandwiched between 2 significant numbers because that 2 and that 1 are significant, so it's sandwiched. So then that would have 4 significant figures. Same thing here, sandwiched, the zeros are sandwiched between significant digits, which makes them significant. So that would have 6 significant figures. Trailing zeros. So trailing, leading are at the beginning, trailing are at the end. Okay, so trailing zeros are only significant if there is a decimal. So if there is a decimal, then our trailing zeros are significant. If there is no decimal, then they are not significant. So in our first one, there is a decimal, so that makes them significant. So that number would have 5 significant figures. In our second one, no decimals, that would only have 2 significant figures. Now, guys, if I give you like an exact number, these are defined, like obtained through counting, or they're defined, they have unlimited sig figs, so they don't count. So if I just told you there was a dozen, that's not going to count for significant figures because it's not like a measurement, it's a counting number. Okay. Now then, you guys, if you went to Heritage last year, you definitely learned, or if you took pre-AP chemistry at Heritage, you definitely learned the box and dot method. So I'm going to go through it really quickly. Box from the leftmost non-zero to the rightmost non-zero digit. If a decimal is present, box everywhere to the right. Count the numbers in the boxes, and that's your number of sig figs. So I'm going to leave most of these for you guys as practice, but I'm going to do one of them with the box and dot method really quickly. So our leftmost non-zero is 2, rightmost is 9. There is a decimal present, so that means I'm going to continue my box all the way to the right. In my box, there are 4 significant figures. Other than that, I'm going to leave that to you guys to work from there. All right. In multiplication or division, we always have to, our answer has to have the same number of significant figures as the factor with the fewest significant figures. So we're going to determine our significant figures, and then our answer needs to have the fewest number of sig figs. All right. So for example, 25 times 15.0. So 25 has 2 significant figures. 15 has 3 significant figures. Our answer needs to have the fewest number, so our answer should have 2 significant figures. So 25 times 15 gives us 375. All right, our answer should only have 2 sig figs. I'm going to move myself again. I always forget. So I need to cut it off right there. And check my rounding. I should round, so I get my answer is 380. Same thing over here. All right, 120 has 2 sig figs. 4 only has 1 sig fig, so my answer should have 2 sig figs. 120 divided by 4 is 30. 30 only has 1 sig fig right now, so it's good to go. All right, I'll leave the next 2. I'll leave C and D for you guys to do. All right, now then, In addition and subtraction, the result carries the same number of decimal places as the quantity with the fewest decimal places. So right here I have 137.1 plus 15.987. So if I add those together, I end up with 153.087. Now 137 has one decimal place, 15.987 has three. My fewest number of decimal places would be 1. So I'm going to end it there. Check my rounding. I should round up because it ends in 0.8. So I end up with 153.1. Okay. And then I'll leave the second one for you guys to do. Now I will be careful here because, actually I'll do that one with you guys because I want to. All right, so for this one, okay, I have 169.89 plus 13.1 plus 20. So 67.89 plus 13.1 plus 20. If I just plug it into the calculator, I get 100.99. All right, so I have 67.89 that has 2 decimal places. This one has 1. This last one has 0. All right, so that means my answer should have 0 decimal places. So my answer is 101. All right. Next, I'm going to quickly remind you guys about how to read scientific equipment. We always report our scientific equipment so that every digit is certain, aka like marked on our labware, except the last, which is estimated. So you're always going to estimate one more significant figure than the equipment shows. So, for example, on this one, all right, each line here represents a tenth, right? Represents a 1. So I would read this as about, I'd say like 42. And then I'm going to guesstimate that last digit. It's not marked, but I'm going to guesstimate it. And I feel like it looks like it's about 42.5 personally there. And kind of same thing on this one. Each line, again, represents 1 there. And so I see about 20, I see like 20, and then I seriously see like 20.0 on my screen for that one. And then for this one, each line represents a tenth. So I have, 7 point, and then I see it as about 7.9, and then maybe 7.9, like 1 or something like that. And last one over here, 8 point, again, every one represents a tenth, so 8.6. That's kind of in the middle there, so maybe 8.65. All right. And then same thing with our rulers, but why don't you guys try to read the rulers and practice guessing that 1 digit of uncertainty. All right, hope this video was helpful. Bye, guys.